Okay, so in order to have the unit testing used, we need to have the test tool basically. Suppose this is the test tool. So what are the inputs that we need? So one is that we need a test script, other one is the implementation of the source code. So what is the output that we can expect from the test tool? The unit test tool, test report, it will generate the report, and automation if we have with the tool we use the coverage report also, it will give how much percentage and all that. Basically this is an optional, we can do it manual also. The test tool requires this test script and source code. Test script is something like the inputs that are required and the value it drives, and the test tool takes that and automates and generate the reports. That's how it is getting used. Test scripts are basically derived from the plan. So it consists of a tester's inputs as the parameters, and expected results also will be there in the script. The script is processed by the tool and converted into a driver, basically driving the source basically. So in a tool like RTRT, the name it is called as a PTU, the driver name. Similarly, LDRA uses its own format. Test report is the results of the test execution, whether it's passed or failed. Coverage report is the how much of total source code have been covered by all the test cases. That's what it does actually. Okay. Okay, so we will try to understand the tool what it does and go through some videos in terms of demonstration so that we'll understand what it is. Okay, so first we'll go through the automated unit testing generation and management. Okay, so we will try to understand the tool called LDRA unit. Basically, this is the tool from LDRA, and the version 9.4.1. So basically, we use this for unit testing, and the source code we'll try to understand what it does. So this is a window where we have LDR unit explorer. So we'll try to explore some of the testing aspects of this LDR unit. So there is a C code selected with this LDRA. Here we have got a file called cache register.c. So we want to do some unit testing for this cache register.c. It's a C file. So you can see the file contents. It explores basically. You can see there are number of functions like add product, count products, end session, etc. You can see it here. Okay. So any function you want to test it alone, like add product. So you can see the parameters it has, the variables that it uses, and whatever the function it calls is all listed here in this LDRA unit tool. It explores basically all these individual functions of this cache register file. You can see the structure passed as a parameter and it is calling tester show, and sprintf. 3 functions it is calling basically. Okay. Okay, so let's start to see how sequence is created in this tool. We need to select the sequence, and we can call it as a unit test add product, something like this. You can add as a sequence, and we are trying to do a code coverage for that particular function with this sequence. We have to select that code coverage option, then test environment, something like setup about stubs. It should create, right, because it has a number of functions. If you want to call directly the functions, it's available, you can use it, and if you don't want, you can create the stubs for those colors. So we can select that automatically create the stubs with that option, and user variables can be global. If it is missing, we can create it, generate it, and different types of test scenarios we can have it here. First option is allowing the compiler to compile the code as a normal one, or the next one is create tests for a subset of code in the source file, the specific usage, because we are interested in this only. We can do this, or isolate fully all code elements. We can do this second option just to create that particular single source file, so that this option is selected. Okay. Okay, so once you select the procedures, it will show that particular procedure, and you can see procedure name and the functions and other details it will display. We can say OK, and we can continue. So it does a basic analysis of this option. So here what's going to happen is you can see the option here, the variable view and the calls view with this option, and any stubs that it has created, it will show here. There is a stub tester show, number of calls is 2, it's a managed stub. So here we go to the function, and we'll right click and create a test case for that particular function now, and it is doing an instrumentation with this, and you can see it's about to create a test case based upon the interface, whatever it is displaying below. Okay. So here test case generation is it could be standard single test case or repetitions, like multiple times we are going to execute with different things. The last one is reported here, iterations, because sometimes what will happen is we want to see the consistency, we can have it something like a robustness, sorry, regression. So in that case we can have repetitions and iterations, etc., or some ranges we can have it simulated by applying a range value. So we'll just try to go with the single test case, the user continue with that. Here you can see the input output view. So there are 2 inputs for this function. There is a structure, there is a value unsigned 32-bit structure, and the output is expected as unsigned 32-bit. So we can click this value input and enter it. We will enter at 0. Then the next one we can enter it as 42, and the output we can expected put as 42. It's an example. Now we'll try to run just this one. You can see the generated test case and the result. You can see here the value for storage, that means the function is going to use this, and the pass fail result based on the expected value versus actual value. So the harness is generated with this, and it has executed and showing the result. So say OK, then we can generate again if you want with multiple inputs like 42 if you want to change it to 50 based on your functions or the inputs for the functions. Of course, the input for the functions is based on the specification of the requirement, so that we'll get the appropriate coverage where multiple statements within the function is being triggered. And you can see here there's a coverage, statement coverage, a branch decision coverage. The current one is 6%, combined is combined MCDC 6%, current is 6% for branch or decision for that particular file, entire file, and that function you can see statement coverage 61% it has hit, and the branch has 60%. We can try it a second time. Second time again, it should say as it was there. So it's a regression. You can see that as a regression pass or fail it shows, and there's no change in the percentage there. So the values are same. It has passed, and the coverage will try to look in particular with the there is a flow graph of the coverage of that particular function. This is interesting. We'll see. You can look at the flow graph. See this here. This flow graph basically saying that executed 2 times. This block executed 2 times. All statements are covered in this block. There are 6 blocks, and it is taking this path after this 4th and 6th. So basically there are 4 blocks that it could execute appropriately, and 2 blocks 3 and 5 are not executed. That is showing in the red. On the right hand side you can see that red marked one which is not executed because it's part of the else portion and it is not executed. So it has passed this one. The portion that is not executed, it is showing in the red one. These statements are not executed because the value that we have given is not enough to execute this. The 5th block is the last one, testers show basket full, something like that. So this is useful to see the flow graph with the coverage. So and generate the test cases, more cases. So you can see it is adding 2, 3, 4, 5 other 4 cases automatically, and it will add up all that test cases and generate the. Now with that, let's see what it has generated. You can see these additional 4 cases automatically it has generated, showing the percentage with these 4 cases altogether is at 100% for that particular function, and for the particular 3, 4 you can see the values it has automatically used based on the inputs that it takes. So you can see in the 4th case unsigned there is an address passed for the structure first input. The second input is a global variable having the value as 50, and the result you can see is as statement coverage as 100% and 100% branch it is covered. So quick overview of this, you can see that is the LDRA unit thing. Still we are not covered 100% of the entire file. C file because we are focused only on that particular function of the file. So that is how the LD array is being used. Further information we can look into ldarray.com, and there is an evaluation version. Probably you can download and experiment more embedded software testing aspects. So that is about the LDRray unit, how automate unit test generation is done, with the help of which we can see the percentage and automatic unit test generation it does. Next type of LDRray unit, it is called the coverage, which also gives the complete coverage of the source code and the structural coverage analysis, which is very important for embedded software industries such as automotive and aerospace. Let's try to understand that also. Let's try to play a demo video for that LDRray cover and try to understand. This is called a LDRray test bed with a tool suite. It is integrated together. So the code coverage we'll try to understand. So here you can see an example of a project for a Keel Trace 32. It's an ARM based target board. Here we'll try to simulate because we don't have a target board actually connected to this tool, and with that we'll try to have the coverage executed. So it's an ARM CPU based C file. So it is called as a TB Vision LDRray. The files that are in the project displayed here, main.c, dice.c, simple files are there. So we will execute the code on the target. Here we don't have a target. We can use the simulator. We use it instead of the target because due to the replacement of the target. So there is a button. We have to press that. It is going to compile this and add the instrument, the source code for the target port, and it is going to build. So there is a compiler. It has inbuilt. It's called Kale compiler. You can see for the LDRray test bed, it is integrated. You can see it is running for that particular Trace 32 simulator, right? What it is trying to do is, as soon as the simulator is triggered, it is trying to stream the message onto the simulator continuously and captures the uploaded value. We can stop at some stage. We can halt with this option, and we can upload the result with this button. The uploaded execution history can be seen here. You can see it is doing the process of that. And we can have a look at what coverage that's generate. We can see the test manager report for this. So you see there is a report for the same. You can see the code review, different types of reviews it does. What we have done here is a test verification, the dynamic report, and you can see and a file that we have tried to execute, main.c and dice.c, and is showing the coverage of statements, branches, and HDC, which we have chosen as an option. You see the percentage where it is 100% is showing in the green, whereas others are shown as red because the coverage is not 100%. Let us try to go inside the particular file such as main.c, you can see the main.c report in particular. It is showing the result in red because the coverage is not attained. Whatever the obtained value is not having 100% coverage because it's 84%, rank decision is 67, MCDC is 25%. That is why it is not definitely compliant. Why it is not compliant? Let's try to understand. You can scroll down and see the main.c has several functions, several procedures such as integer to ASCII, display value, etc. And main itself two type of tests like statement and branch are no issues because 100% coverage is there, whereas the inbuilt integer to ASCII library or the function has only 79%. And the coverage that we obtained is for this particular integer to ASCII is statement is 79, branch is 58%. And you can see that particular function ASCII to integer, and you can see the last 2-3 runs, current run, previous run, and the combined run, how many times it has run with our simulator, and it will show the calls, number of calls, what are the statements that are being called, and how many decisions it is able to drive together with every line of the code it is showing. So you can see the stars which are not at all executed showing us 0 times because the values that it requires has not attained. So some of the lines we have executed more than the earlier ones, like 700 plus times it has executed. Some of them executed 114 times. So likewise. Okay, so that's how we can see the report. So one more approach is also there. You can delete all the results. We can change the instrumentation technique with other option. This analysis we can use it and generate instrumented programs automatically. With this, we can configure instrument the code. We can compress the execution. We can compress into a structure. We can start the analysis of this selected automated instrumentation. Let's see. And again we can say run on the target. This instrumented code, it is simply captured all the iterations, and inside the structure is going to populate all the analysis. Now we can upload the execution history. We can analyze the code it has built already. Okay, let us halt the current running execution of that instrumented code and see what is the result of this. Now it is analyzing the files. So let's select a project, view the test manager report and see what is the report shows. Now we can see main.c how many times we have executed integer to ASCII, every line of code how many times. Now you can see here one time executed these lines of code here with the instrumentation. We haven't executed this again because we want to have a coverage. We can see a code overview with that option. You can see there is several overview. We know that entire project has showing as failed because it is short by 14% in terms of the statement, and the brand decision is 68. And if you are not able to cover with instrumented or non-instrumented, then that 14% or 32% of branch decision we need to do manually or some way of doing it with the other approaches. That is what we need to do for the LDRA tool. Okay. Okay. So basically, what we need to do is for coverage testing, we need to have a source, we need to have a script, and appropriate selection should be LDRA tool and execute it, and we need to establish the coverage with coverage tool, then structural coverage analysis for the entire project like this, and generate the different metrics in terms of statement, decision coverage, and report the entire set. This is what we have done. The earlier demo we have stubbed a function and create the unit testing with the help of LDRA unit test tool. Okay. So with that we will end today's session on the practical thing about exercise 3. In the next practical session we will take up the next one and demonstrate the next practical demonstration. Okay.